Permanently frozen soil is called as your permafrost. Okay, permanently frozen soil is called as your permafrost. If you go to the polar belt above the latitude of 60, you go here and here, soil there has top cover of snow for around 7 to 9 months. So for 2 to 3 months it melts. It melts and it flows away, and the underlying soil that is there, that soil is exposed. So below you have soil, above you have snow. So this soil now gets exposed. This soil now will have water or moisture. Any soil has water or moisture. And you have to realize this soil has more water or moisture because it is covered by a top layer of snow. The snow is here, first snow penetrates inside also. So inside there is a deep layer of soil which is filled with moisture like this. Very deep moisture filled soil. Now the sunlight received in this region only is so low because equator is here. Sun rays have to reach here. Sun rays reaches only once in 6 months, that too very less amount. Otherwise, other 6 months they are in darkness. They have polar night and they have polar day phenomena. So that region is in darkness. When there is in darkness, there is no light only. So now during daytime in summer season, they have 24 hours of day. In that day also the sunlight received is less intense. That less intense sunlight will not be able to dissolve this water, or sorry, melt the water. What happens when the soil is covered with ice? Here you have ice on top. Land is cold, freezes the water inside the soil. So when you touch the ground in your area in winter season, when you touch the soil, you'll feel moisture. You'll feel that the mud is wet and it is sticking to your hands. It might not be as wet as you plant the when you water your pot. When you water your pot, it is absolutely sticky. But otherwise, also in winter, when you go to the outskirts area and you touch the soil, you will feel that it is moist. It might not be exactly wet like your pot, but it will be moist. It will kind of stick to your hand, so you have to dust it. Because moisture is there, it will stick to your hand. Otherwise, like sand, it will flow away from your hand. It will not stick to your hand, so it will stick to your hand. So there is moisture. Now this moisture in winter in this polar region gets frozen inside the soil also. So they get converted into tiny ice crystals here. And next summer, when there is your heat or sunlight, it is not enough to melt it, cannot melt it. So inside the soil always there is frozen water. The heat that is received can only melt this part. Are you able to understand?
Yes, ma'am.
Okay, it is melting only this part. It cannot melt the ice crystal, small ones, which are there inside the soil because heat is not that intense. Okay, for example, you cannot cook biryani with candle. You need one LPG. Okay, you need LPG or you need firewood. Intense fire is required for it. You cannot cook biryani with a candle, so it is something like that. So it cannot melt the ice crystals that are there in the soil. It holds the soil together now because soil is kind of solidified. This is called as your permafrost, where the soil is permanently frozen even during summer. Global warming is there now. Global warming increases the temperature. This global warming, when it increases the temperature, inside whatever ice crystals are there, they start dissolving. When they start, sorry, when they start melting. They start melting. So when this ice crystals now melt, it adds lots of water. When an ice crystal melts, it adds lots of water. Soil mixes with this, and soil starts moving or flowing. Solifluction occurs. Soil starts flowing very slowly, like a river, and you see collapse in landform. Collapse in landform. Whatever carbon was trapped now comes out. Whatever was frozen and traps comes out. Second is, because it was frozen, there was no decomposition of prehistoric fossils. Whatever animals were there in ice age, they are trapped inside. Ice age, whatever humans died, whatever animals died, they were trapped inside. It has not undergone decomposition, so it has not released methane. If it undergoes decomposition, it will release methane also, it will release carbon also. Okay, so it has not underwent decomposition only. Now, when the temperatures are increasing, it is undergoing decomposition. If it undergoes decomposition, then microorganisms are acting on it. Microorganisms start releasing methane. Okay, so now it has started decomposition of your prehistoric fossils. So that is why whenever they are going for hunting your fossils, etc., you see them, they go to polar area. Polar area, because all the fossils are preserved very carefully under the cover of ice in cold temperature. Finding fossil is very easy, and you will also find it in a good state. So that is why you see fossil exploration in your foreign countries is very high, because they are living in cold climatic conditions. Fossils are preserved. In countries like India, the temperature is so high that easily it decomposes and it is lost. Okay, decomposition rate is very fast in tropical countries. When you go to your polar countries, the rate of decomposition is slower, because microorganisms do not grow in your in your cold areas. That is why you keep your food inside the refrigerator, because it is stopping decomposition. If you keep it outside, by morning it starts smelling bad. And even when you see, if you keep some curry, or if you're keeping something, okay, so when you keep curry like structure outside, and by morning when you see it, there will be bubbles on it. So if you keep it beyond rotten stage, you'll see that it will start bubbling. It is bubbling because there is activity of decomposition going on by microorganisms, and they're releasing methane. So when you shake it, you have methane coming out, and you have that methane decomposed, chemical structure has changed, methane is also mixed. That is why that sour taste, and you feel that the food has gone bad and you cannot consume it. So that is why you throw it. When you keep it in the refrigerator, the microorganism is prohibited from multiplying or acting, because it cannot act in low temperatures. It requires a minimum of 10 to 12 degrees for it to multiply and for it to act and change the chemical composition. So in cold temperatures, it cannot do its activity of decomposition. So you preserve the food. Same activity has happened here. Just like how you keep a body in frozen ice box, okay, after death, because you want to slow the decomposition process and you want to preserve the body for 1 or 2 days. The same thing happens in this case also, where fossils are preserved. Now these fossils have started undergoing decomposition. This is releasing immense amount of methane, high amount of methane, which is not reversible.